When we normally think of sugar, we think of that sweet white crystal that we put on stuff to make it taste good. However, just like everything else, sugars are molecules, and in the next few minutes we're going to be breaking down a few molecules that are classified as sugars. Those are glucose, fructose, and sucrose. And to start us off, we'll look at a simple sugar molecule called glucose. So here's a picture of glucose. It is a crystalline white powder, and it's also called blood sugar. And that is because it's present in our blood, and in fact it's the sugar we burn for energy. So glucose is used by all living cells to burn for calories. Here is a simple structure of glucose. It actually has two structures. It has this one, which is a kind of line structure, and another one, which we'll see in a second, which is a ring structure, which is this. A few characteristics of glucose: it melts at 146 Celsius, it boils at 527 Celsius, its molecular formula, C6H12O6, it's soluble in water and acetic acid, and what obviously the body uses it during cellular respiration, so it's going to be glucose becoming energy and some byproducts. And what people use it for is they inject it directly into the blood to provide calories for people who can't eat normally for whatever reason. So here's the makeup of a ring structure of glucose. It has some alcohol structures on the outside, and on the inside we have this cycloalkane with an ether component here. Obviously you can't really give glucose benefits because it's obviously necessary for life to occur, but if the body can't manage glucose, then it's dangerous because either too much or too little can throw your body way off and can be fatal. One example of not being able to regulate your glucose is diabetes, where your glucose is too high. So glucose is normally produced through photosynthesis in plants. 6 carbon dioxide and 6 water react to form due to sunlight, to form glucose and 6 oxygen. And the way we burn glucose is the opposite. Glucose and oxygen produce energy that we use to go about our day, as well as a byproduct of water and carbon dioxide. Fun facts about glucose: there are about 1.6 times 10 to the 24 glucose molecules in the average body. So we're going through a lot every single day. So next is fructose, which is a very similar compound to glucose. It's visually similar as most sugars are. They're all crystalline white powders. And the common name for fructose is fruit sugar because it's found in most fruits and vegetables. Here is a ring structure for fructose, but it can also have a line structure just like glucose. It has the same molecular formula as glucose, C6H12O6, and similar melting and boiling points. It's also soluble in water, and fructose is what people use it for or one main use for it is it's combined with glucose and some other elements to form a syrup-based sweetener called high fructose corn syrup. And this is used in a lot of foods, primarily soft drinks, which are pretty much always sweetened with this high fructose corn syrup. So the makeup here is a ring structure of fructose. It has more alcohols and another cycloalkane with an ether. One notable thing about fructose is that when it's undefined and unrefined in fruits, it does not appear to have any health risks, and that's how it should be, since we humans have had millions and millions of years, or animals have had millions and millions of years for their metabolisms to evolve to be able to handle fructose. Unlike other sugars, which we've just invented in the last few thousand years and haven't been able to adapt to yet. But if fructose is refined, you lose a lot of those benefits, and it can put strain on the liver. It can cause heart disease and diabetes, which we talked about earlier, and it's linked to weight gain as well as, and it also can be addictive. So this is the Calvin cycle. I'm not going to go much into it, but it's a chemical process where glucose and fructose are combined to form sucrose, which I'm going to talk about in a sec. And sucrose is is table sugar, which is like the regular sugar we eat. But we'll get to that when we do. One fun fact: grapes have the highest concentration of fructose than any other fruit, according to the fruits provided to me by Google search. So quickly comparing glucose and fructose, here are the ring structures of glucose and fructose, and here are the straight line structures, and here we can kind of see the difference. The fructose molecule has the oxygen in a slightly different place than the glucose molecule, and the glucose here, this is an aldehyde structure, whereas this is a ketone. Finally, we have sucrose, which, as you can see here, is regular old white sugar, table sugar, whatever you want to call it. You know all of this already. What sucrose is you can see here, it's actually a glucose and fructose molecule attached by this oxygen here, or similar to that in structure. You can see the two rings in this GIF here. What sucrose is used for, obviously, it sweetens stuff. Like I said earlier, you use it to make stuff taste good. So here we can see the makeup again. We have the cycloalkanes surrounded by alcohols on either side with the one ether in each, and that's just glucose and fructose. And then these two molecules are combined together by this one oxygen ether. So benefits of sugar versus other sweeteners are that it's considered healthier than a lot of other sweeteners, because it's considered healthier than high fructose corn syrup and like artificial sweeteners, which you see in like 0-calorie beverages and sugar-free stuff and all that, are often carcinogenic. So unless you're consuming a lot of sugar, which you shouldn't be. If you want to just have food high in sugar or a sweet food, it's best to just go with something with sugar in it. But once again, if not regulated, or if you eat an unhealthy amount of sugar, it can lead to diabetes, it can lead to heart disease, it can lead to weight gain, and it can be addictive. So sugar is produced in synthesis reactions in the Calvin cycle, with glucose and fructose coming together to form the sucrose molecule, and that can be found in sugarcane as well as beets. But here's a little diagram as for the refining process of sugar. So it's crushed, and the juice is what's going to contain the sugar, and then the rest of the biomass is used to heat up this juice and evaporate all the water to condense that. And at this point, once all the water is boiled away, you get this syrup, which is called molasses. And all of the extra debris that kind of make the molasses brown is removed in this centrifugation stage, where it becomes refined sugar. And if you don't refine it completely to white sugar, that's what brown sugar is. And this white sugar you're going to use to make your desserts, your candies, your chocolate, your pop, although that's not accurate. It's high fructose corn syrup. So a quick history of sucrose. It was discovered in 500 before Common Era in sugarcane-like grasses and extracted through crude methods. But it was only discovered in Europe in the 11th century during the Crusades. And then during the 18th century, when some nations were finding it hard to trade, they came up with a new way of extracting sucrose from a new plant, which is the sugar beet. And now the sugar beet provides 30% of the world's sugar. It's the same compound, sucrose in both cases. And yeah, before we end, I would just like to say that it's sort of interesting how all of these reactions synthesize sugar, and it becomes kind of more complex, and then you eat it and it gets broken back down into glucose and cellular respiration, and you end up back where you started with carbon dioxide and water. Yeah, anyway, thank you for watching. It's been fun, and yeah, see you soon.